All right, we're going to talk about bisectors and triangles today. So, concurrent, when three or more lines intersect at one point. So that's what we're going to be looking at is what happens when three perpendicular bisectors intersect a triangle where they actually meet the point of concurrency, the point at which the lines intersect. Okay, so these points of concurrency actually have a lot to do with it. All right, so concurrency of perpendicular bisectors theorem. Okay, the perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So what's really happening here is this point right here, J, is actually the center of a circle, and the radius is going to be AJ, JC, or JB. And so what happens is it's this circle that is centered around at J. Okay, so that's what the perpendicular bisectors are going to do. The nice thing is that what happens is J, since it is the center of a circle, and A, C, and B are on the circle, the radius, which is AJ, JC, JB, are all the same. And so J is equidistant from all those vertices. So this is called the circumcenter, is the point of concurrency of the perpendicular bisectors, point J. So the circumcenter, okay, you probably noticed that it's like really close to circumference, the circumcenter, because we're dealing with a circle here. So we're going to find the circumcenter of a triangle. Okay, so here's my triangle. It's pretty straightforward. The nice thing is if I can find where two of the perpendicular bisectors intersect, I know the third one has to intersect there either. So this is a right triangle. So I'm actually going to do the sides that are perpendicular to each other already. So here I have AB. So AB is 8 units long, right? So from 5 to -3, 8 units long. So in the middle at 4, this would be my perpendicular bisector. Okay? And now I'm going to go from B to C. Well, B to C, -1 to 5 is 6 units long. So I got to go up 3. 1, 2, 3. Here's my perpendicular bisector. They're going to intersect right there. So this right here is my circumcenter. And I'm going to label that as D. And if I were to come in here like this, that sets up my next piece there. Okay, so now I have found it. I actually didn't really find D here. I kind of use a little bit of simplicity. If I don't have a nice right triangle, what am I going to do to find point D? I would actually have to draw in, use my compass, and go over half and draw my perpendicular bisectors on at least 2 of those. Okay, but this is a nice one. It's perpendicular. Anytime we're doing perpendicular, use the 2 sides that are perpendicular to find your circumcenter. Okay, so now we're going to use the circumcenter. Okay, so in this, the example is asking to find a place to put a fire department that is equal distance from A, B, and C. So this would be a high school, a middle school, and an elementary. So could we find a place where we could put a fire station equal distance all of these? Well, what we're going to have to do, this is not a right triangle, so we're actually going to have to create our perpendicular bisectors. Okay? So I'm going to find my perpendicular bisector, BA. Okay. So I take it there. There's my first perpendicular bisector. I'm going to use my straight edge here. Okay. So there's my first perpendicular bisector. I'm going to go to BC, and I'm going to do the same thing. So now I'm going to find my perpendicular bisector of BC. Make sure this is more than half. It's pretty close. Okay, so there's my perpendicular bisector of BC. And this is going to be, might be a little off because, but so there is my point D where I'd actually want to have my fire station. So the distance from BD, AD, and CD are going to be the same, okay? So if I were to come in here, this should be match up here. So that should be my perpendicular bisector for AC. Okay, so it works a little bit better if you have a compass and a straight edge. Okay, so now we're going to talk about concurrency of angle bisectors here. Okay, the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of a triangle. So here, now what's happening is we're taking a circle and inscribing it inside the triangle. So this point here, I, is the radius of the inside circle, and it is equidistant to each side of the triangle. Okay? And that is called the incenter. The incenter of the triangle is the point of concurrency of the triangle bisectors of a triangle, point I. Okay, so that's the incenter. Okay, so here we have our incenter. So we're asking for the length of GD. Well, if GE is 2x minus 7 and GF is x plus 4, what is GD? Well, remember that EG or GE is equal to GF. So I have 2x minus 7 equals x plus 4. I'm going to subtract off my x. I get x minus 7 equals 4. I'm going to add my 7. I get x equals 11. Okay? Now, the problem is I don't have a algebraic expression for GD. But that's okay because all of these have to be the same value. So I can actually find GF, which is x plus 4. That gives me 11 plus 4, which is 15. Well, that's GF, but if we remember, GD has to equal GF. So GD is also 15. What is the best state to buy a new soccer uniform? Well, New Jersey, obviously. And why is a football stadium always a cool place to sit in? Because it's full of fans. All right, so that's kind of getting you to understand circumcenter and incenter. Circumcenter is the point of concurrency of the perpendicular bisectors. Okay, so and how those two centers relate within the triangle.